data control, compression, and normal point. When you measure the satellite data, is like that. The measurements that you have are actually, let me see, something like this. And these are DR. These are the, I have measured a satellite passing from here, and I have measured the range, and the range is changing like that for the satellite. But how can we get the data from it? So normally a reference orbit can be considered for that, and this reference orbit can be average of this orbit, or you can have a predicted orbit from for the mathematical or the orbit determination, orbit integration. So if we subtract this reference orbit from that one that we have observed, we get a smoother orbit like this. So this smoother orbit actually, what should we call it? Let's just get dr. Actually, this is d0. dr, actually dr is d0 minus dp, the predicted one minus the observed one. Now I try to divide this part, the smaller pieces, the smaller classes. Then these small classes, for each small, I take an average of the signal. I take an average. I have, for example, measured these values here over this class and take the average. The average will be somewhere here, over here. So this average is called normal point. Normal point. Therefore, the distance between the dr, which is in the orbit, using this dr, from this fr, is fr, and this is f bar, or this is the average. Then you can give this average, this distance around this real orbit, and this normal point as an error for the measured distance. So if I write this, if I write the equation of the normal, the NPI, which is the normal point, here is the observed point, and the class I minus FR I minus F bar RI. So F bar and F bar is this one, this distance, and DO is the reference distance that you have measured. So in this way, you will smooth and somehow reduce the noise of the data, noise of the measurements by this technique. And normally, this normal is the observables for the SLR system. So if you work with the data of SLR, you will work actually with the normal point.